Good morning, students. Today, let us learn chemistry, grade 9, second part. What is that second part? Seas and rivers. Seas and rivers. We stopped last class till global warming. Now, let us continue from seas and river. Is it clear? Now, sea and river are the natural resource again. Here, now what we should know, the distribution of water on the earth. Distribution of water on earth. Water on earth. Okay, now let us see. Now I will draw the images like this. First one, what is this? Now I'll tell you. Now this, just think this is a globe. In this we have 3%. We have 3% fresh water. You understood? 3% fresh water. The remaining all are salt water. 97% is salt water. Is it clear? Now what is the percentage of water available for us? It's only 3%. In that 3%, I will draw again one more. Assume that this is 100% now, that 3% here. In that 3%, 68.7% is ice caps and glacier, okay, and this 0.9% is others, okay, and 30% of this is groundwater. That means I will take this as surface water. Is it clear now? Or what I will take this as? Surface water. When I take as surface water, that 3% here, so 68.7% is ice caps and glacier, correct? And here others are only 0.9%. and 30% is a groundwater. Is it clear? Now, this is one part here. Okay. Now, I will take this little more bigger. One more, this one I will draw. In this, if you see, like this, here you will find 87% is lake water. I am just zooming like this. That means I am just comparing one by one so much. So how much we are going to get? So here 2% is river water. Is it clear? And here 11% is swamps. Clear? So this is how the water distribution on the earth is here. Now let us do an activity. I will do an activity in this so that you will understand better. Now if you see the activity in this, which is there in the book also, I will show you both. Where you understand better, first I will explain and then we will compare that with our book. Is it clear? If you see here, it's very clear. I will assume, I'll take a beaker and I will assume 2200 ml of water present on earth. Is it clear? Total water present on earth. Total water present on earth. Clear? Now, how many ml is that? 2200 ml. That means we'll assume that in a beaker containing 2200 ml is the total water present on the earth. From this, I will take 12 spoons of that. I will take 12 spoons of that. How many spoons I am taking? 12 spoons. Full. 12 spoon full of water into a container. From this, I say. Now, what is this? We'll compare. Now, this is the fresh water. This is the fresh water. Fresh water. What is consists of fresh water? Ice caps, glaciers, river, lake, and groundwater. Is it clear? Now, from this, you take two spoons. Take 2 spoons in a petri dish or in a china dish. Okay, I'll take 2 spoons of this. From these 2 spoons, I'll take one ink filler. From that ink filler, I will take 1 drop into another container. This 1 drop. Somewhere here 1 drop will be there. Now this is our river water. No, this is our river water. Is it clear now? Now I am comparing. That means I am showing in this topic what we are reading. Seas and what we learn. We are reading seas and rivers. So I showed you seas is 97%. The river is here. This 1 drop compares with the river. That is the presence, the activity for this subject. Okay. Now, if you see here in the book, it is showing here also the same thing. So the surface water contained in the barrel, it is showing that 100 dm cube, and 3 bottles of that is your fresh water dm cube, and from that taking 1 spoon of that is 3 centimeter cube is your really present water, that is your other waters. Is it clear? What is this now? Here in this book it is showing that readily accessible water. Yeah. Is it clear? In your book it is showing that I compared this activity for you. So for your clear understand. Is it clear? The next part what we are going to do, we have water treatment. Water treatment is extended for you. Anyway, I will just explain a little thing. Here it is given a small part of that water treatment. I'll just show you what is it. Water treatment. Is it clear? Now, how the water has to be treated before it is reaching us. Okay. That means coming to our house. For example, Kaveri water may be your corporation water may be. Okay. Your town municipal water, whatever you compare. Okay. Now, what is happening here is, first one, rainwater, Kaveri water. So, rainwater, this is rainwater. The rainwater is collected. Rainwater is collected. That is collected in the dams. Okay. From this dam, the water is pumped to the other. So other container. Now, just think this is one more. This one, where here the top layer, there the top surface of the floating organisms or floating dry leaves all are removed in this. Okay. What we say now here, that means what? First water is collected in the dams. Okay, from there the water is pumped. Okay, and it is pumped into one more tank there. In this tank, the floating organisms or the floating dry leaves, whatever may be, all are removed. From this again, the water is pumped into the next container, that is next tank, if you say next tank, and aerated. We have an aerator. It's like a fan aerator. Okay, so when you aerate the water, all the unwanted particles are getting settled down. Okay, the water is getting purified here now. From here, the water is passed into the sand filter. Okay, it is passed into the sand filter. From this sand filter, the water is taken. That means each step in the water treatment, we are observing. Here, activated charcoal is added. Activated charcoal. Charcoal is added to remove all the colored particles or if it's a rainwater, you get that brown color. All these colors have been removed here, and here it is a sand filter. Okay, from here, from activated the sun, the water passes into a chlorination tank. Here also we chlorinate, 2 times we chlorinate. Here also we chlorinate, here also we chlorinate. Okay, chlorinate. Correct, two places we chlorinate. After this, it will pass through the filters. It passes through the filter. Depends 1 micron to 0.01 micron. From there it reaches to our house. Okay, correct. This is our source, final source, tap water. Okay, this is how the water treatment is done. Okay, now next one we learn earth crust. After this we learn earth crust. Now this is how the water has been treated. Clear? Now let's learn earth crust. In that earth crust, we will come across rock cycle and limestone cycle. 2 we come across in that. That's what we are supposed to read. As I told you, carbon cycle, oxygen cycle, nitrogen cycle, phosphorus cycle. All these are extended. So what we have to learn is only a part of that. Let us see what is that. Now, earth crust. This one we are continuing, the earth crust. What is that earth crust? The earth crust is a top layer of solid rocks of the planet. On decomposition of this, they release carbon dioxide and water to the atmosphere. Okay, now as this leads into the different layers of rocks. Now how these rocks are formed now, that is how we are coming to a rock cycle there. The different layers of these rocks are formed. This movement leads to the different types of rocks. So all these are happening because of volcanic eruption. Is it clear? Now under this we'll study about rock cycle. Now, do you know that rock is growing? It's a non-living, but rock is growing. How? There is for 1 year it grows by 1 centimeter. For 1 year it grows by 1 centimeter. It is powered by radioactive decay. It is powered by radioactive decay. The planet of the Earth crust are moving only a few centimeters each year. That's a very small thing. That means this is a rock means very small layer is increased. Small layer is increased for every year. Every year 1 centimeter is increased. Okay. Now the crust of various in the thickness from 5 kilometers. It could be 5 kilometers below. 5 kilometers below. Okay. That means depth below. Correct. Some parts of the ocean are around 50 kilometers. Some parts of the land mass also. So from 5 kilometers to 50 kilometers around ocean. Around ocean. Is it clear? Now that means you can see this rock wherever the rock is present. So that means see when you are digging bore also you can see some stones are there inside. Okay, you can see some sound will be getting when you are digging a bore. Okay, that means what rock is present everywhere. Correct. But what we see the rock is the raised ones. Okay, but it is there below the earth also. The distance of the surface is 6,000 kilometers. 6,000 kilometers. In this we find the metal ores. We find metal ores, rocks, metal ores. Okay, rocks can be used for building also. So rock can be used for building also. Building. You can see they cut the pieces of stones and they are building. If you see Europeans, foreigners, they used to build buildings with stones. Still you can see St. Joseph College. If you see that old building, all big stones are there in there. Okay, that means olden days they used to use rocks. Now only they are using all concrete blocks. Correct. So ores are also extracted from the rock. So even they say now diamond is also are present below the rocks. Okay, all these are happening because of the volcanic eruption and the geothermal energy. That means because the heat is there below the surface of the earth also. Is it clear? Now that completes your this one rock cycle here. Let's go to limestone cycle. Next one is limestone cycle. Limestone cycle. What do you mean by limestone? What is limestone? Limestone is nothing but calcium carbonate. Calcium carbonate. This is called as limestone. Here, this calcium carbonate, I put like this. This calcium carbonate we converted to calcium oxide. This is called as quicklime. What do you call this as? Quicklime. Quicklime. This is called as quicklime. Again, this calcium oxide gets converted to calcium hydroxide. This is your slate lime. This slate lime, by adding water, more water to this slate lime, and by what do you call that? Adding carbon dioxide to this, by adding water here, more water, here I am adding carbon dioxide, so again it will form calcium carbonate. This is called your limestone cycle. Limestone cycle. Understood now? That means calcium carbonate on decomposition gives calcium oxide. This is called calcium oxide. Calcium oxide. This calcium oxide, by adding water to this, okay, it becomes calcium hydroxide. And adding more water to calcium hydroxide becomes same calcium, that is your lime water. This is your lime water, because slate lime. on again by pumping, by bubbling carbon dioxide into this, it becomes calcium carbonate. So the cycle completes like this. Now what you have to remember is here, the limestone is an important resource from which the useful range of compounds can be made. So first what it's made, quicklime is made. Correct. A piece of calcium carbonate can be heated strongly with some to produce quicklime. Okay. So that means you are heating it. When you heat this, you get calcium oxide. Fine. Next, the piece of lime is allowed to cool, and then a few drops of water is added to the solids, will expand and selected into the reaction here. This is called an exothermic reaction because heat is liberated. Exothermic reaction. Heat is liberated. Fine. Now by adding water to this and bubbling carbon dioxide, it will come back to calcium carbonate. So this lime cycle completes it. Correct. Now this is how this become. Now here when you add this water too much to this, it will become alkaline. That means it increases its pH. So finally it gets converted to calcium carbonate. That completes your lime cycle, limestone cycle. Correct. Next one is fossil fuels. You can check your book. I am following one by one. Next one is fossil fuels. What are fossil fuels? Non-renewable resources. These are non-renewable resources. How they are formed? They are formed after a very long time. Okay, millions of years are taken to manufacture fossil fuels. So fossil fuels, what are fossil fuels now? Here fossil fuels, we get coal, we get petroleum product, that is called petrol. We will extract petrol and diesel. Okay, the next one, here so these are the and minerals here. Fossil fuels will not take the minerals. So coal and crude oil. One more is, what is that? Natural gas. Natural gas. Okay. Now these are the main fossil fuels. If you see now it is 2020. 2020. We are in 2020. Now what has happened? Now whatever fossil fuels like coal, petroleum and natural gas present in the earth crust has been utilized. How much it is utilized? It is utilized, fossil fuels are utilized now, which has supposed to be for 43 years. Now itself we have utilized it. Which is supposed to be for 43 years, we have utilized now. Now itself it is utilized. Next one, petroleum products, it has to be there for 167 years, but we have completed now itself. Now natural gas, it has to be for 417 years. Okay, this source are present in the earth crust for so many years. We are supposed to use like this. Now what we are doing, we have completely taken it off. Okay, which is supposed to be for 43 years, now itself we utilize. Which is supposed to be for 167 years, we have utilized now itself. Which is supposed to be for 417 years, we have utilized now itself. Is it clear? Now, correct. Now this supports. That means what? This now what has happened? Now you can see book is given. What is that? The comparison of the fossil fuels. Okay. How they were used. Okay. Between the years they are given. I'll just write that this one. Sources of petroleum products. 2006 comparing now. 2006 here 2011 comparing. Now petroleum. Petroleum 36.8, 31.1. Okay, correct. So this is on the percentage. Fine. Next, coal 26.6, 33.1. This is the report between 2006 and 2011. Now this is 2020. The latest one will come later. It's not till given. Natural gas 22.7. Here 23.7. Hydroelectric power. Hydroelectric power 6.3, 6.4. Clear? Next, nuclear energy. 6.3, no sorry, 6.0 and 4.9. You can see this is the comparison given. Next, all renewable resources like solar energy, wind energy. Okay. Next is what? Hydro energy. All these 1.4%. Now it is 1.6%. So now this is the status given. Okay. Now this in 2006 it was so much. Now in 2011 it is showing so much. Okay. Fine. That means what? We have to stop this petroleum product. Okay. And nuclear energy. These two we have to stop and go for the alternate source called solar energy, wind energy, or hydro energy. Is clear? Okay, hydro power plants. Clear? Now, if you are switched on to this, now you can see now already electric vehicles have come. Okay, and electric cars have come already introduced. Okay, now if we see this, we can see we can minimize the petroleum products. Okay. Now, if you see Brazil, they are using ethanol. You know what is ethanol? Alcohol. C2H5OH. Ethanol. This ethanol is an alcohol. Okay. They mix different flavors and they call it whiskey, brandy, all this they are going in the market. But here, this ethanol is getting converted. The ethanol they are using as a fuel for cars, two-wheelers, three-wheelers. Correct? Now, when ethanol burns, it gives carbon dioxide. Okay. When petroleum product burns, it gives carbon monoxide. Okay. This is dangerous gas, and this is nothing else. Carbon dioxide. It's not serious to us. Because we are also giving out carbon dioxide. Okay. Here the pollution is reduced, and they are not at all depending on the petroleum products. They already. That means for ethanol from where they get? From the sugarcane juice. Okay, once we manufacture sugarcane juice, that unwanted waste we call as bagasse, that is thrown, and from that they convert this ethanol. Okay, now next one, we will see renewable resources. What is that renewable resources? Renewable resources. Now, if you see renewable resources, first one, I'll put it in center. Okay, first one, hydroelectric power. Hydroelectric power. Next one is geothermal. Geothermal. What is geothermal? Energy. The energy getting from the soil. The next is wave, tidal, wave. Wave power. And a tidal. Tidal. Okay. Next one, wind power. Okay, the next one is biomass. Biomass and biogas. The next one is solar. Solar energy. This is how the renewable resources are being distributed we are getting all this resource from all this 6. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, now renewable resource to reduce the fossil. Why I'm showing this chart here? You can utilize all this to minimize non-renewable resources. Okay, is it clear? Now the next topic is hydrogen as a fuel. So if you see, we are using hydrogen as a fuel. Correct. Now where you get hydrogen? Very simple. If you see in Chennai, one engineering student has conducted an experiment. He made a car to run on water. See. Okay, now this is water now, H2O. This water is broken down to H plus and OH minus. Okay, so this hydrogen is used as a fuel, hydrogen fuel. This hydrogen used as hydrogen fuel. Okay, to run the vehicles now. Okay, now if you see here, I just write it. Hydrogen gas has an attraction. That means this fuel is very clean fuel. If you compare this, hydrogen fuel is very clean. No pollution. Okay, nothing, no pollution, no toxic substance. And when this vehicle runs on this hydrogen fuel, okay, carbon dioxide is released, and there is you don't get that means here in this hydrogen fuel cell, okay, this water is taken into this, and here one of the catalysts acting on that, so it breaks the water into H plus and OH minus. Okay, this hydrogen fuel burns, it uses the vehicle to run. Okay, pollution is free, no pollution. Okay, nothing is there, nothing is going to come out from that. Okay, it is very free now. Okay, now let us see what is that now. If you see hydrogen, this is what is this method called? This is called electrolysis method. Electrolysis method, correct? Splitting of H plus and OH. Right. Okay. Now water is taken into the tank, in the 2-wheeler or 3-wheeler or 4-wheeler. Okay, and this electrolysis is happening inside the tank, and then the hydrogen fuel is used. So that means what? Now we have to what is the advantage of hydrogen fuel? Means our engines are not supporting this, so we have, that is a disadvantage. Now we have to redesign the engines as per the hydrogen fuel. Okay, now you can ask me one more question, whether these are safe. No, it is very dangerous to store this hydrogen fuel, because it has a low density. Correct. Now efficiency, if you ask me, efficiency, if you ask, it is showing 60% hydrogen. When you burn hydrogen, it's showing 60%. When you are taking petrol or diesel, it's showing 35% efficiency. You can see 60% efficiency is there, but it's very good and it is very difficult to store this, otherwise it catches fire. You should be very careful. And I will show you now. If you see already in the US, now where you are using hydrogen fuel cell means in US, first space they use that to in the vehicle, first vehicle to run the hydrogen was the rocket of US space program. Okay, so they started using in spacecraft. Okay, hydrogen fuel. The next one, if you see Japan, Nissan and Mazda, these are the two companies. In Japan, these two car companies, they started using this. So the car has been designed on this hydrogen. Nissan and Mazda. And the next one, BMW and Daimler Benz. in Germany. Here, so they start in Japan, and in Germany they started using hydrogen fuel in their cars. Is it clear? Fine. Now that completes your chapter here. Okay. Now I'll give you some questions. Make a note. What are the advantages and disadvantages of using hydrogen fuel? What are advantages and disadvantages of using hydrogen fuel? First question. Second question. What is briefly what is limestone cycle? What is limestone cycle? Okay. Next, third question. Write an activity on distribution of total surface water on earth. Clear? Now I want an act. These are the 3 questions you have to do. The next class we'll go for the next chapter. Okay. If you want to see the hydrogen, even the school vans are in it. You can see there. Okay, hydrogen fuel. You can see the car here. You can see the school van. Correct? So this is the process. Because this is an extended, I need not explain you. Otherwise I would have gone a little more depth. What is happening inside, which catalysts are used. Okay. You can see this is all extended. You can see this is the engine inside. How it is getting converted. Right. That completes your chapter. Thank you. Stay safe.